Hello, welcome to the final hands-on session on word embeddings. So we are at the point where we have used the pre-trained GLOW word embedding in order to perform the text classification along with the help of logistic regression ML technique. So by that we have achieved a accuracy of 0.97 and 0.96 as a test accuracy. So we can also do it with a different approach, that is we can build our own word embeddings. So for that the very first step is to create the input data. So for that what I am going to do, I am going to create this X combination. So X combination where it will be np.concatenate both the training and the test data set. So here we don't have any restriction over that, right? So we can create the entire data as a input, right? So for that what I am going to do, I am going to concatenate both the x and y x training and x test data. So by that I will be achieving total records of 7674. We can also have a look of what are all the words or the input data after combining the things. So next, the very next thing is to initialize the word embedding. So I am going to create a word-to-vec word embedding. So initially I have used a pre-trained model, right? For that I have used GLOW. Now I am going to build our own word embedding using word-to-vec. So for that what I am going to do, I am going to pass this combined X data. I am going to set the window as to, here the window would be nothing but the skipgram. We are going to enable this skipgram approach, right? So we have going to generate the skipgrams to feed the input to this word-to-vec. So I'm going to set this skipgram equals to 1, and I'm going to set this window as 2. That is, we are going to use 2skip1gram method in order to generate the word embedding. So also the size of the word embedding, I'm going to set it over here itself. So I'm going to expect the word embeddings to be of the size 200. So we can use 100, 300, 200, any size, but here when compared to 100, 200 would be more sufficient or more better yielding results when compared to 100. But what if we use 300? It will be outraged, or the whole model will be by hearting the entire patterns available in it. So we instead of using the extremes, I have just chosen the middle one. So I am going to expect the word embeddings, that is word-to-vec embedding of the dimension 200. So now I have initialized this word-to-vec. Now it's time to check it out whether it is performing well or not. So for that I am going to use this the same most similar function, that is the in order to check what are the neighboring words for this word feature. So if I just pass the word feature, you can see it was appeared along with the near, prospects, methods, etc. So by this we can say that we have initialized the model very well. Now it's time to perform the same set of things we have conducted in order to perform the word embedding the text classification using the pre-trained GLOW word embedding. So there what we have done, we have converted those word vectors or the singular token vectors into sentence vectors by averaging out the words, right? So the similar steps I am going to conduct it over here again. So I have initialized this function, a sentence vector. I am going to pass each and every word vector into this sentence vectorizer, and I am going to take the average of each word vector, and I am going to get the sentence vector. It's nothing but I am taking the word vector of each individual words in a given sentence, and I am going to average it out in order to get the sentence vector. So by this we are reducing the size of the input, right? So instead of accounting each and every token vector, I am just taking the entire sentence vector, right? So that's what the reduction of the size what I am going to conduct over here. So once that I have defined this function, I am going to pass the training and test data over here. So here you could see I have iterated over the x that is trained data. So I am going to iterate over here, and I have also removed the stop words, and I have passed those stop words filtered sentences words into sentence vectorizer. So this will yield me the sentence vector. So it will be the sentence vector for each and every sentences instead of word vectors. So I am ready with the train vectors or the train sentence vectors. I am also going to perform the similar activity for the test data as well. So now I am available with the both training and testing data. Now I am going to use the same logistic regression model with all the similar parameters over here. So I am going to use the same set of parameters which I have set over here. So which I have conducted for the pre-trained glow word embedding. So we just have a confirmation on that. Okay, just a second. Yeah, so this is the penalty which I have set over here. So I am going to use the same logistic regression model over here as well. Okay, so I am going to set that as well. Then I am going to fit that logistic regression model with the training data and along with the label. Then once our model is ready, the logistic regression model is ready. Now I am going to predict that on the training and test data. So I am going to store those values in this prediction underscore train dot ys and prediction underscore test dot ys. Then I am going to check the accuracy. Here you could see we could able to achieve a accuracy of 0.97 and 0.96. Can you remember this exact values? This is same as multi-class Navy bias classifier, right? So here you could see this is the multi-class Navy bias classifier. It was able to achieve an accuracy of 0.96, but on a mentioned condition that it had a 5,000 features, that is 5,000 dimensions of the word embedding, right? So there was no concept of word embedding over here, right? Each and every word is considered as a feature, so there was 5,000 features. So the model was very heavy and the performance of it would be taking more time in order to predict this text classification. But now what we can see that we have achieved the same accuracy with the reduced set of features, right? So we are just available with the dimension only 200 dimensions at the end of building this model, right? So because we here we have set that size as 200, then the word to vec embedding which we are available with will be of size 200. So by this what we can conclude that these word embeddings can outperform the normal or the simple Navy bias classifier with two key advantages. That is, the size of the overall model would be reduced, and also the performance time or the training time or the prediction time would be greatly reduced by using these word embeddings, and we can achieve the similar accuracies when compared to the normal Navy bias classifier. So by this we have concluded the overall hands-on session of usage of word embeddings in order to build a text classification model. So by this we can also understand that these word vectors or the word embeddings can be used for any other text dealing examples, right? So we can use this for clustering, categorization, topic modeling, etc. in order to get the accurate results in order to get accurate results over the Navy bias classifier. So in the last final session, what I am going to do, I am going to just build a spam ham classifier using a deep neural network structure without using any word embeddings or anything, and we will also check out how that is different from our word embeddings.